Ever get that feeling, like you've blinked and suddenly it's Tuesday? Or maybe you're stuck in traffic just wishing you could, I don't know, just zap yourself home. Well, today we're taking those kinds of everyday feelings about time and space and really cranking them up, way up. We're diving deep into the actual science behind time travel and shortcuts through space. Really mind bending stuff. You sent in a fantastic collection of material on this, and we've sifted through it to pull out the most intriguing, maybe even surprising bits.
Yeah, and it's fascinating, isn't it? Because science fiction often treats, warp drives and time machines as totally separate ideas.
Right, like Star Trek zooming around and then Doctor Who popping back to see the dinosaurs, different things.
Exactly. But what these sources really highlight, and what's genuinely interesting from a physics perspective, is this deep, um, unexpected connection between traveling faster than light and potentially traveling backward in time.
Okay, so you're saying that figuring out warp speed, like in Star Trek,
Yeah.
that might actually be the key to time travel too.
It seems weirdly intertwined, yeah. We'll definitely get into how Einstein's ideas about space and time being flexible, almost like a fabric that can be bent or warped, how that opens up these possibilities.
Like cosmic loopholes, wormholes, and things.
Precisely. And this isn't just, late night speculation anymore. The core source we looked at, Time Travel and Warp Drives by Everett and Roman, really lays out how physicists have been seriously grappling with these ideas.
Seriously, like actual
Oh,
physicists.
yeah. They point to a key moment, actually, a paper from back in 1988 by Morris, Thorne, and Yurtsever. It was about wormholes and time machines.
1988. Wow.
And the big deal was that it used Einstein's general theory of relativity as the basis. It kind of legitimized the discussion within mainstream physics.
So before Einstein, this was just pure fantasy, but his theories gave it a mathematical possibility.
Well, even his earlier theory, special relativity, had hints. That's the one that established the speed of light as the ultimate speed limit.
Right. Nothing goes faster than light.
Correct. And within special relativity, if you could somehow break that limit, you run into all sorts of weird paradoxes, including potentially arriving somewhere before you left.
Okay, that's the classic time travel headache right there.
Exactly. But then comes general relativity, his theory of gravity. And this is where it gets really interesting for shortcuts,
How so?
because general relativity merges space and time into this single thing, space-time. And it says space-time isn't just a static background, it's dynamic. It can be curved, warped, stretched by mass and energy.
So gravity isn't just pulling stuff down, it's actually bending the shape of the universe around it.
That's the picture, yeah. And if space-time can be bent and warped, maybe, just maybe, there are ways to create shortcuts, loopholes around that light speed limit,
Like wormholes, the things you see in sci-fi all the time.
exactly like wormholes.
Yeah.
General relativity doesn't forbid them. Mathematically, they're possible. Think of them as tunnels connecting distant points in space, or maybe even time.
Like in Deep Space Nine or Stargate.
Yeah, those are great examples. The idea is a direct consequence of the theory. Now, that 1988 paper was important because it didn't just say, hey, wormholes. It asked, okay, what would it take to have one that's stable and, big enough to actually travel through?
Right, because a microscopic one that vanishes instantly isn't much help for getting to Alpha Centauri.
Not really, no.
Hmm.
And their analysis suggested you'd need something pretty strange to keep it open, something called exotic matter.
Exotic matter. Okay, bookmark that. Sounds important. What about warp drives then? Like the Enterprise.
Right, warp drives, another theoretical concept rooted in general relativity. The idea here isn't to break the light speed limit within spacetime, it's to warp spacetime around the ship.
Like surfing. Riding a wave of space-time.
That's a great analogy, actually. The Alcubierre drive is the most famous proposal. You create a bubble. Space-time gets squished in front, expanded behind. The bubble moves, potentially faster than light relative to distant observers, but the ship inside the bubble is just chilling. Locally, it's not breaking any rules.
So the ship stays still, but space-time moves around it. That sounds complicated.
Extremely.
Yeah.
And likely requires vast amounts of energy, possibly that exotic matter again. There's also another idea, the Kresnikov tube.
A tube, like a space-time subway.
Sort of. You'd essentially pre-build a corridor of distorted space-time between 2 points. Now, the initial trip to, say, build the other end of the tube might take years at sublight speeds.
Okay.
But the return journey through the already existing tube, that could be almost instantaneous, arbitrarily fast.
Whoa, wait, so you go out slowly but come back instantly.
Yeah, and if you went far enough away, so lots of time passed back on Earth while you were traveling out.
You could get back before you left, or at least way earlier than you should have.
Exactly. That's the time travel connection again. Building one of these could potentially function as a time machine into the past.
Which brings us right back to paradoxes, doesn't it? The grandfather paradox.
The classic one, yeah. If you go back and prevent your own existence, how did you go back in the first place? It's a logical nightmare.
Seems like the universe wouldn't allow that. Like it would just stop you somehow.
Well, there are ideas about that. One, kind of humorously called the banana peel mechanism in the sources, suggests maybe the laws of physics just intervene. Something always stops you from creating the paradox. You slip, your equipment fails, whatever.
The universe throws a banana peel under your feet. I like it.
It's fun, but not very satisfying scientifically. A more philosophically deep idea comes from quantum mechanics, the many worlds interpretation.
Many worlds, like parallel universes.
Kind of. The idea is that if you go back and change something significant, you don't actually alter your past. You just cause the timeline to branch, creating a new parallel universe where things happen differently. Your original timeline remains untouched.
So you can't actually change your own history, you just spawn an alternate one.
That's the proposal.
Yeah.
It avoids the direct logical contradiction. Still pretty mind-bending, though.
Yeah, no kidding. Okay, let's circle back to that exotic matter needed for wormholes and maybe warp drives. You said it's strange.
Very. Specifically, these solutions often seem to require matter or energy with negative energy density. This violates something called the weak energy condition, which basically states that energy density should always be positive or zero.
Negative energy. Is that like antimatter? Because antimatter sounds pretty exotic.
Good question, but no. That's a common misconception. Antimatter has positive mass and positive energy. When it meets regular matter, it annihilates and releases a burst of positive energy. Negative energy density is something else entirely, much weirder.
So where would you even get negative energy? Does it exist?
Theoretically, maybe. Tiny amounts might occur in quantum fluctuations in vacuum, like in the Casimir effect, or possibly near black holes via Hawking radiation, but these are incredibly small-scale effects.
Not exactly something you can mine and put in your warp core.
Not even close. And there's another catch. Quantum inequalities.
Yeah.
These are theoretical limits developed by physicists like Ford and Roman on how much negative energy you can have and for how long.
So the universe puts limits on it. Like, okay, you can borrow a tiny bit of negative energy, but pay it back fast.
That's a pretty good way to put it. And the bounds seem really strict. To keep a wormhole open long enough and wide enough for travel, the amount of negative energy needed might have to be confined to regions smaller than an atomic nucleus.
That sounds basically impossible with any technology we can imagine.
It's huge challenge. It might mean that macroscopic traversable wormholes or practical warp drives, as described by these specific models, are just physically forbidden.
Are there other ideas for time travel that don't rely so much on this exotic stuff?
Well, there are other theoretical models. Some involve rapidly rotating, infinitely long cylinders. Another involves moving cosmic strings, hypothetical defects left over from the early universe.
Infinitely long cylinders. Cosmic strings. That still sounds pretty far-fetched.
They have their own massive hurdles, yeah, often requiring infinite structures to get around certain theoretical problems or truly astronomical amounts of energy or density. They're interesting theoretically, but don't seem any more practical right now.
It sounds like physics keeps putting up roadblocks. Didn't Stephen Hawking have something to say about this too?
He did. He proposed the chronology protection conjecture. Basically, he suspected that the laws of physics themselves have a built-in mechanism to prevent time travel to the past.
The universe protects its own timeline.
That's the gist. Maybe trying to create a time machine inevitably leads to some instability, like runaway energy fields or quantum effects, that destroys it before it can actually work. A kind of self-preservation for causality.
Okay, so wrapping this up. Faster than light travel and time travel seem linked through Einstein's theories. Wormholes and warp drives are theoretical ways to do it by bending space-time, but they hit this wall of needing negative energy, which seems really hard, maybe impossible, to get in large amounts. And even then, paradoxes and maybe Hawking's conjecture stand in the way.
That sums it up pretty well. It's a fascinating area where theoretical physics pushes right up against concepts we usually think of as science fiction. While building these things seems incredibly unlikely based on what we know now.
The very act of exploring the possibility teaches us a lot.
Exactly. It forces us to probe the deepest aspects of gravity, space-time, and quantum mechanics. Even if the answer is no, you can't do that, figuring out why is incredibly valuable knowledge.
So for us, the learner, the takeaway isn't necessarily get ready for time travel next Tuesday, but more about how weird and wonderful the universe's rules might be, right? And how much we still have to learn.
Precisely. And the book ends on that note, too, asking, how sure can we be of our current conclusions? Physics has changed dramatically before. What might future discoveries reveal?
Yeah, it makes you wonder, could our descendants look back at our ideas about the impossibility of this stuff the way we look back at people who thought flying machines were impossible? It's definitely food for thought.
A lot to chew on.
Yeah, absolutely. Well, if this dive into warp space-time has got you thinking, checking out the source material, time travel, and warp drives is a great next step. There's so much more detail there. Thanks for joining us on this temporally complex deep dive.